Hello everyone, we are first year students from the Department of Journalism and Communication Studies. Today our topic is Resilient Infrastructure, the tuned mass damper of Taipei 101. This is our content. Introduction. The core of SDG 9 is building resilient infrastructure. A great example is the tuned mass damper, which uses dynamic balance to offset energy. By upgrading infrastructure for sustainability, we improve both occupant comfort and structural safety. This demonstrates how scientific innovation leads to safer, more stable cities. This golden ball is Taipei 101's tuned mass damper. It's the second largest in the world, weighing a massive 660 tons. Since Taiwan gets a lot of typhoons and earthquakes, its main job is to keep the building steady. It absorbs the wind's energy so people on the top floors don't feel seasick. Most buildings hide their dampers, but Taipei 101 turned it into a golden landmark that you can actually see up close. It's basically the heart of the tower. Here are three famous examples of buildings that also use dampers: CN Tower, Crystal Tower, and Citicorp Center. It absorbs and dissipates building energy caused by wind or earthquakes through its own counter oscillation as external forces move to the structure. This massive golden sphere shifts its response, absorbing kinetic energy to minimize weight. This enhances occupant comfort and ensures structural stability.
Next, we are going to see link of SDGs 9. First, developing resilient infrastructure. In Taipei 101, a 660-ton TMD near the top of the building helps reduce wind during earthquakes and typhoons. When the building moves, the steel sphere swings in the opposite direction to counter the motion. This lowers structural stress, prevents damage, and keeps people inside safer and more comfortable under extreme conditions. Second, upgrading infrastructure and industrial sustainability. Tuned mass damper helps buildings like Taipei 101 reduce shaking during earthquakes and strong winds. By lowering structural stress and damage, it extends the building's lifespan and reduces the need for frequent reconstruction. This helps decrease construction waste and supports more sustainable and resilient infrastructure. Third, scientific research and technological innovation. Taipei 101 provides valuable real-world data on earthquakes and strong winds, helping engineers study how water buildings respond to extreme conditions. Research on this TMV and seismic systems improves building safety and drives innovation in high-rise construction technologies.
After that, I will talk about practical applications. I will divide it into two parts. First is the typhoon, and the second is the earthquake. About the typhoon solar in 2015. First of all, the TMD at Taipei 101 recorded a swing amplitude of plus or minus 100 centimeters, and the total displacement is 2 meters. Last but not least, this typhoon is the most sensitive activation frequency which TMD measured, and TMD is refers to town mass dampers. Next, I will talk about the Shenzhen earthquake in 2022. First of all, TMD of Taipei 101 recorded a significant swing amplitude of 20 centimeters. And the second is when the earthquake happened, TMD helped reduce building vibration.
Challenge. Some people may wonder whether the two mass damper of Taipei 101 is expensive. In fact, the main damper cost about 4 million USD to design and install, which is only a small part of the building's total construction budget. Routine maintenance mainly includes inspecting cables, dampers, support systems, and sensors, as well as checking performance after typhoons or earthquakes. These costs are relatively minor compared with the building's total operating expenses. In return, the damper helps reduce the damage, lower repair costs, and extend the building's service life. The technical challenges can be divided into three categories. First, design difficulty for extreme events. The system must withstand both strong earthquakes and severe winds while controlling building motion without causing excessive movement of the damper itself. Second, system aging and monitoring requirements. Over time, cable elongation, hydraulic leakage, and sensor degradation may reduce performance, so continuous monitoring and regular tuning are necessary. Third, public perception and risk communication. Many people believe the steel ball alone keeps Taipei 101 safe, while ignoring the importance of the whole structure system, including the steel frame, concrete core, and foundation. Therefore, public education should emphasize complete resilient infrastructure rather than only one device. Reflection. Taipei 101's two main damper demonstrates the innovation value of structural engineering in enhancing urban resilience. It not only protects the building itself, but also urban safety, economic stability, and social confidence. For the SDG 9, this can inspire other high-risk cities to introduce advanced seismic and wind damping systems in skyscrapers and critical public infrastructure to improve the resilience of urban facilities, and use innovative technologies and sensor-based monitoring to reduce long-term disaster risk and economic losses while promoting sustainable urban development. In other words, Taipei 101's two mass damper is not merely an engineering achievement. It is a concrete practical example of how to connect industry, innovation, and infrastructure and move toward more resilient and sustainable future cities. Thanks for your listening.